Notice that the approach speed target, V approach, has now appeared as a magenta triangle. The aircraft will continue decelerating toward F speed. By reducing toward F speed, the aircraft will be below the VFE for the next flap setting. Flap 3 can now be set. Click on the flap lever. As before, VFE next and VFE move to reflect the new flap position. Flaps full can now be selected. Click on the flap lever. The aircraft will eventually stabilize at V approach, and the VFE will be adjusted to reflect full flaps. There are indications associated with speed and angle of attack protections. These protection indications will be discussed in the flight control modules. Once the aircraft lands, all additional speed indications are removed except for the speed trend arrow. Having thoroughly studied the airspeed indications, let's look at altitude indications. All the indications associated with altitude are located on the right-hand side of the PFD. The main part of the display is dedicated to the altimeter. To the far right is the vertical speed display. We will look at the altimeter indications first. The middle part of the altimeter contains a green digital readout of altitude. The red ribbon to the right of the altitude scale represents the field elevation. The ribbon is currently level with the center of the scale. Like the airspeed indication, a gray analog altitude tape moves behind the digital display. In this example, there is a target altitude of 17,000 feet displayed. On the Flight Control Unit, FCU, there is an altitude selector, which shows the current selected altitude. At the bottom of the altimeter is an indication of baro reference. In the example shown, the QNH is 30.08 inches. The baro reference setting is achieved by a selector with associated indication on the EFIS control panel. The baro reference may be changed from inches of mercury to hectopascals by rotating an outer selector. To look at the various other indications on the altitude and vertical speed scales, we will run through a typical flight profile. The aircraft is on the ground. Notice that with a QNH of 29.92, the altimeter shows 10 feet. The aircraft is airborne. The vertical speed indication is showing a climb of 3,400 feet per minute. The aircraft has now been cleared to flight level 330, so the new target altitude has been set. On passing the transition altitude, the standard pressure setting must be set by pulling the baro reference knob on the EFIS control panel. Notice that the baro reference indication has changed to STD, and the target is now shown as a flight level. The aircraft is now cruising at flight level 370. Notice that the target flight level box is in the middle of the scale, and the vertical speed indication is at 0. At the transition level, the baro reference is set to show QNH by pushing the baro selector knob on the EFIS control panel. In the final stages of an approach, the ground reference ribbon will reappear, along with the landing elevation line. Notice that the vertical speed indication is showing a rate of descent of 800 feet per minute. Also notice that the missed approach altitude has been set at 9,000 feet. When the aircraft lands, the ground reference ribbon is in the middle of the scale and the vertical speed indication is at 0. We will now look at the compass scale. The compass display is very conventional. The gray scale moves against a fixed yellow line, which represents the center line of the aircraft. In the example shown, the aircraft is on a heading of 091 degrees. The small green diamond represents the aircraft track, and it is normally referred to as the track diamond. In the example shown, the track is 094 degrees, which means that the aircraft has 3 degrees of drift to the right. A selected heading may appear either as a blue figure on the appropriate side of the compass scale or a blue triangle. On the FCU, there is a heading selector with an indicator that is linked to the selected heading indication on the PFD compass. There is a direct relationship between the small white ticks on the horizon line of the attitude indicator and the compass scale. As the heading changes, the ticks move to stay in line. Now, let's look at how ILS information is displayed, and in particular concentrate on the compass scale. The ILS switch on the EFIS control panel enables the pilot to switch on an ILS display. The ILS display includes indications for localizer, front course, glide slope, information. ILS deviation information is displayed in the form of localizer and glide slope deviation scales. The ILS front course will be displayed in magenta at the side of the compass scale if the figure is outside the visible scale. A magenta diamond represents the localizer. When the ILS front course is within the compass scale, it is displayed as a magenta dagger. In the example shown, the aircraft is established on the localizer, and the glide slope indication has appeared in the form of a magenta diamond. The aircraft is now fully established on the ILS approach. Let's look at the indications on the compass scale in detail. With the aircraft established on the localizer, the heading is 230 degrees. The track diamond is showing 3 degrees of left drift. The ILS front course dagger is beneath the track diamond. You will see how useful the track diamond can be to help you fly an accurate approach in the simulator phase. You will be given more information on the ILS system, the flight director, the radio altimeter, and the flight mode annunciator indications later in the course. Now, let's look at another useful indication available on the PFD, the flight path vector. The flight path vector can be displayed on the PFD to show you what the aircraft is doing in relation to the world. It is an indication of the aircraft flight path. It is not a director. The green symbol, sometimes called the bird, represents the aircraft. The attitude indicator represents the world. Let's look at the FPV in a bit more detail. To begin with, we will look at the indication for an aircraft in level flight with no drift. For training purposes, we will exaggerate the angles. The aircraft heading and track are the same, so the flight path vector and the track diamond are in line with the heading marker. These indications mean that the aircraft is not drifting. The aircraft is flying level with the pitch attitude of 9 degrees. The FPV is on the horizon line, so at present the flight path angle is 0. That is, the aircraft is in level flight. Now let's enter a descent and see what happens to the flight path vector. The flight path vector will move down to indicate the angle at which the aircraft is descending through the air. This is known as the flight path angle. Now let's introduce some drift to the left. As a result of wind from the right, the aircraft is drifting to the left. Let's now look at a typical example of how the FPV indication would look for an aircraft established on an approach. The aircraft is fully established on an ILS approach. Notice that the flight path vector is in line with the track diamond, indicating left drift. The FPV is below the horizon line in a 3-degree descent angle.